Hello everyone, my name is Vidya and in this session I'm going to discuss on prime numbers. Now, why am I going to discuss prime numbers? The reason is because prime numbers are a very essential concept that is used in any encryption algorithm. Okay, so as we go further in the encryption algorithms like RSA, elliptic curve cryptography, Diffie-Hellman key exchange, etc., you will understand that these encryption algorithms extensively use prime numbers. Now, why do they use prime numbers? I'll explain that in the next video. But before that, it is essential that our concepts on prime numbers very crystal clear. So first we should learn what are prime numbers, what are composite numbers. Then in the next video, I shall be covering what is prime factorization and why is prime number essential in designing any encryption algorithm. Therefore, the contents of this session is we'll be learning the difference between a prime number and a composite number. So let us start this session. To begin with, what is a prime number? So any number is said to be prime if it satisfies three conditions. What are the three conditions? First and foremost, it should be a whole number. What do you mean by whole number? Whole number basically means integers. It should be either 1, 2, 3, 4, 5 and so on and so forth. It should not be a fractional number. It should be a whole number. Second, a prime number is greater than 1. So 1 is not a prime number. The reason for why it is not a prime number, I'll discuss it in the next slide. So 1 is not a prime number. So prime numbers start from 2, 3, 4 and so on and so forth. So greater than 1. And the third point is a prime number is exactly divisible by two numbers, that is 1 and by itself. That means if I have a number n and I want to check if this number n is prime, what are the conditions? First, it should be a whole number. It is not 1. It is a number which is greater than 1. And third condition is that the number n should be exactly divisible by only and only two numbers, 1 and itself. What is itself? N. So in order for n to be prime, it has to be divisible by 1 and it has to be divisible by n. Let us now see some of the examples. Before we see the examples, the concept of prime number should be crystal clear in our mind. What is a prime number? A prime number is a number which is exactly divisible by only two numbers, that is 1 and by itself. So with this condition to check whether a number is prime or not, let us go ahead with testing if these following numbers are prime or non-prime. Non-prime is also called as composite. I shall discuss it ahead. So let us first begin by checking number 1. Now what do you mean by divisible? Divisible means when you divide the number with any other number, the remainder has to be 0. Okay, so when the remainder comes out to be 0, it means that particular number is divisible by the other number. So a number 1, if divided by 1, turns out to be 1. But if a number 1 is divided by 2, the answer comes out to be a fractional number. If the number 1 is divided by 3, it comes out to be a fractional number, and so on and so forth. So if you see here, the only number with which 1 is divisible is 1. So here you can see that 1 is divisible only by 1. Now, since 1 is divisible by only one number, it is not prime. Okay, so 1 is not a prime number. Why? Because it is divisible by only one number. Now let us check the next number 2. So if I take 2 and divide it by 1, I get 2. If I take the number 2 and divide it by 2, I get the number 1. But if I take 2 and divide it by 3, I get the answer as 0.67. 2 divided by 4 is 0.5. 2 divided by 5 is 0.4 and so on and so forth. So if you see here, 2 is only divisible by 1 and 2. So 2 is divisible by 1 and itself, that is 2. So it satisfies the condition and hence 2 is a prime number. Okay, let us check the next number, that is 3. So you take 3 and divide it by 1, so you get 3. 3 if you divide it by 2, you get 1.5. 3 if you divide it by 3, you get 1. 3 if you divide it by 4, 0.75. 3 if you divide it by 5, you get 0.6. So after this you get all fractional numbers. So if you check, 3 is divisible divisible by these two numbers. So 3 is divisible by 1 and by itself, that is 3. So is 3 a prime number? Yes, 3 is exactly divisible by two numbers, that is 1 and by itself, that is 3. So 3 is a prime number. Okay, so in this case 1 is not a prime number, 2 is a prime number. Why is 2 a prime number? Because it is divisible by 1 and by itself. 3 is a prime number. Why is 3 a prime number? Because 3 is divisible by 1 and itself. Let us see more such example. Let us test if number 4 is a prime number or a composite number. If you check 4 is divisible by 1, 4 is divisible by 4, but it is also divisible by 2. So what is the condition that we require? Condition is a number n is prime if it is exactly divisible by only two numbers, 1 and by itself. Since 4 is divisible by 3 numbers, 4 is not a prime number, so it is a composite number. Why is it a composite number? Because 4 is represented by multiplying prime numbers. So 4 can be represented with prime numbers. So any number which is represented with the help of prime numbers are called as composite numbers. So 4 is made up of prime numbers. It is called as a composite number. Let us now test if 5 is a prime number. So 5 can be divided by 1. So if you divide 5 by 2, it is 2.5. It is a fractional number. If you divide 5 by 3, it is again a fractional number. If you divide 5 by 4, it is again a fractional number. Well, if you divide 5 by 5, it comes out to be 1. So if you see that a number 5 is a number which is divisible by exactly two numbers. So since 5 is divisible by only two numbers, that is by 1 and itself 5, 5 is a prime number. Let us now check out if 6 is a prime number or a composite number. So if you divide 6 with 1, you get 6. If you divide 6 with 2, you get 3. If you divide 6 with 3, it comes out to be 2. There's no need of doing further because the given condition for a number to be prime is it should be exactly divisible by two numbers, while here you see that 6 is divisible by more than two numbers. 6 is divisible by 1, 6 is divisible by 2, 6 is divisible by 3, 6 is divisible by 6. And therefore, since 6 is divisible by 4 numbers, 6 is not a prime number. Rather, 6 is a composite number. So what a composite number? Composite number is basically a number which is product of prime numbers. Since 6 is made up of 2 into 3 and 2 and 3 both are prime numbers. So 6 is made up of product of two prime numbers. 6 is a composite number. Let us now check the number 11. So 11 is a number which can be divided by 1 and it can be divided by 11 itself. If you divide 11 with 2 or 3 or 4 or any other number, you will get fractional number. Therefore, since 11 is divisible by only two numbers which are there by 1 and itself, that is 11. So 11 is a prime number. What about 15? So rather than dividing, we can check it out this way as well. So 15, as you all know, is product of two prime numbers 3 and 5. So since 15 is a product of two prime numbers, 15 is a composite number. Okay, what about 16? Now 16, as you all know, can be represented as 4 into 4, that is 2 square into 2 square, or you can represent it as 2 raised to 4. Since 16 is made of prime number 2 and since 16 is divisible by many numbers, 16 can be divided by 1, 16 can be divided by 2, 16 can be divided by 4, 16 can be divided by 8 and 16 can be divided by 16 itself. So it is divisible by many numbers. 16 is not a prime number. Okay, it is a composite number which is made up of prime number 2. So we can represent 16 as 2 raised to power of 4. Since it is made up of 2 raised to power of 4, it is not a prime number, it is a composite number. Now kindly note that whenever we want to test if n is prime, what were we doing? We were dividing n with 1, we were dividing n with 2, divide n with 3, divide n with 4 and so on and so forth till you divide n with n. And the required condition was that if n is divisible only by 1 and only by n, then in that case the number n is said to be prime. Now, if n is a small number, this task is very easy. But what if n is a large number? Okay, if I give you some number which is so large and I ask you to check if it is a prime number or not, then it is not possible for us to divide a large number with 1, 2, 3, 4 till we reach that large number n. It's not at all feasible. So what do we do in that case? Therefore, in order to test if a number n is prime or not, we do a primality test using the algorithm which is called as Miller-Rabin algorithm. So if you want to test if a number is prime or not, the standard algorithm that is used is known as Miller-Rabin theorem. It is a test used to test if a given number is prime or composite. I shall be covering this particular theorem in my coming videos. So with this we come to an end of this video. Thank you guys for listening to the video. I hope it was useful to you. In the next video I'm going to teach you what is prime factorization and what is the significance of prime numbers in cryptography. So see you all. Stay healthy, stay blessed.